All right, a quick video on lesson 7. There's no new information here, but you're going to be combining all the different laws that we've done. So you need to look at lesson 6, 5, 4, 3, and figure out the exponent laws that we're doing. So example 1, this is the product law, which says we add the 3 exponents. So this would be A, and just add the 3 exponents, and you're going to be left with A6. Example 2, this is the quotient rule. So the 2 coefficients here, they don't have exponents, so you divide them as normal. So negative 48 divided by 8 is positive 6. And then the c squared and the c, the quotient law says that we're going to subtract the exponents, and same with the d's, so 4 minus 1. So you're going to be left with 6cd3. Here's another example. So inside the brackets, BEDMAS says we still deal with the brackets first. So looking inside that bracket, is there anything that can be simplified? And I'm going to highlight the m squared and the m. Now if we isolate that stuff, m squared over m, that's the quotient rule. So you subtract the exponents and you're just left with m, and it's going to be in the numerator. So let's simplify it a little bit. So we're left with 3m n7, and now we have another exponent 5. So this is the power rule. So we're going to apply this exponent to all 3. So you get 3 exponent 5, m exponent 5, and m exponent 35, because you multiply the exponents. All right, what is the value of all this stuff? This is a PAT question, so it looks daunting. The first thing we want to look at, though, is this 3 to the 0 exponent. That's equivalent to 1. So let's simplify it just a little bit. So that becomes 1 squared. And let's simplify this bracket a little bit here as well. So that's going to be 4. And it's raised to an exponent of 1. Okay. Then let's deal with this exponent here. Negative 1 squared is positive 1. Negative 1 multiplied by negative 1 gives us positive 1. Okay. And then we've got 4 to the exponent 1 is just 4, and this is still being squared. So let's move it up here and use a little bit more room. I'm going to rewrite it so we're not doing a step out of place. Okay. So then let's apply this negative. So that's going to be negative 1, subtract 4 more is negative 5, and negative 5 squared is positive 25. So you'd fill in 25. All right, another PAT question here. The expression blah, blah, blah can be simplified to a single power. Okay, so let's do the product law first. So n34 is going to be n12 over n squared. And then let's look at this bracket here. So really what we have is n10 divided by n5 multiplied by n squared. So the first set of brackets is going to be n, and then subtract the exponents because of the quotient law. And then n10 minus 5 because of the quotient law, but then adding 2 because of the product law. Okay, so we have n10 multiplied by n, 10 minus 5 is 5, plus 2 is 7, and then n10 multiplied by n17, that's the product law, so you add those 2 exponents, so we're left with n17. So the value of the exponent is 17. All right, how many expressions shown above have a value that's larger than 3 exponent 7? So the first one is 3, 8. This one's going to be 3, 8. This is being added, so we need to actually evaluate what these things are. So 3 to the exponent 5. Let's see if we can get a calculator here. So 3 exponent 5 is 243. And 3 exponent 3 is 27. So if you add those two, you're going to get 270. I guess we should evaluate what 3 exponent 7 is. 2,187. Okay, so this is definitely not bigger. 310 to the 0 exponent, well, this part here is just going to become 1, and 1 squared is just 1, so that's definitely not larger. This part, 3 multiplied by 2, so this is going to be 6 exponent 6 over 2 exponent 6, which we can calculate here. So 6 exponent 6, let's clear it first. 6 exponent 6 divided by 2 with an exponent of 6. So that comes to 729. Definitely not bigger. And 3, 8 minus 3, 4, 3 exponent 8 minus 3 exponent 4, 6,480. So that one is larger, so is that one, and so is that one. So we're going to have 3 that are larger than 3 exponent 7. Typically this would be a calculator section question. And then we're on to the assignment. Okay, so you have to look back and figure out which rule do I need to use, and don't try and do everything at once, especially when you get to something like this. Okay, don't try and do it all at once, do one step at a time.